Hey, good morning everyone. It's Anagon Live, and today is day 20 of Adventive Code. I want to know how everyone is doing. 20 days or 19 days of puzzles of programming, and they are getting quite hard. I am personally running behind. I haven't finished day 18, and I haven't finished part 2 of day 16. I'm very much stuck on the maze. I have an algorithm that could technically solve it, but it takes just too long. If there's anyone who has a great tip or insight for me to solve day 18, the one where you have to open all the doors with all of the keys, I would be very happy to know that. I see that a few people have solved day 18 in fact, so let's look at the statistics. But you can see from the curve that day 18 was definitely a harder one than the ones before and after. Even after more than 24 hours. Okay, well, around 2,000 people have solved it until the second part. So it's not too bad actually. But for me, I'm still stuck on the first part, and I have tried all kinds of heuristics, but it just doesn't seem to work. So any tip towards optimizing it is greatly appreciated. I'll show you how far I got so far, and I'm not sure if my maze can actually be printed right now, because I did change some of the code yesterday. But basically, if I run it, you'll be able to see that I am calculating the paths to every key. And I am caching it also based on the tip, so that I can basically cache all the paths from every key to every other key. And every time you see this phrase coming up, calculating shortest path, then it means it's not cached. And after some time you'll see that every path is pretty much cached. It goes faster and faster. Nubali, you're saying, for me day 18, we first tried a too complicated solution. A quite simple search with memorization did the trick in decent time. Quite simple search. And did you do a breadth first search then, or a depth first search? And did you search step by step or key by key? Breadth first search. And I'm wondering why my algorithm cannot find it, because I'm using quite a simplistic heuristic, and I think it returns very similar values for different paths, which means that technically it should be doing a breadth first search, but it just takes a long time. How long did your code take to run, Nubali? So in the screen here you can see that it's evaluating different paths, and it has now done 500,000, and memory is increasing also. And Zarankiewicz, you did breadth first search to find which keys are reachable from the current state, but you used brute force with memorization to try all possible order of the keys. Okay. Right. And did you do a breadth first search in a single phase, like in a single step or pass, and then in the second pass you did the brute force? Or did you do the brute force first, and then at every step use the BFS to figure out the reachable keys? In Nubali's, yours runs in a minute. That is very fast. Wow, maybe I am making it too complicated then. So what I am doing, I am starting from the center position and tracing all paths to all keys. Then I am looking at how many doors are on the way for each key, like which doors. And so that gives me a dictionary of dependencies for each key. And then I basically go over all the keys that we don't have but that are reachable. And I'm using the keys that we do have to figure out which doors are already open and which are reachable. And then I'm appending all of the next possible keys that we could find onto a big list which is sorted by a heuristic, and then I'm always trying the first one. And that just takes forever. And Zarankiewicz, for the second version, you did a brute force overall that first calls BFS. Yeah. Well, maybe we can have a look at how you solved it. I am very curious at this point, because I'm not sure why my solution is so slow. And also, do you guys have any idea how many positions you've evaluated? Like, so now it's been doing 1.7 million. But what should I be able, like, what should I expect? And by the way, I'm not evaluating every possible order because I'm doing prefixes. Maybe that's the difference. I'm not trying every key order, I'm trying every prefix until I find an order that is complete. And then I'm hoping that the first one I find is the best one, but it's not guaranteed actually. I think even though I'm doing A star, I'm not exactly sure. Yeah, I think I should find the quickest one first. Yeah. If you're doing it naively, you have 26 factorial to check. Yeah, and that is a lot, right? I looked at that, of course. That is a number with 26 zeros, which I think is going to be impossible. Like mine does about 1000, maybe 4000 per second. So that means so many hours, and it means so many days, so many years. That means, well, a lot of years. A number with 15 zeros. That's how many years it would take. That would be about 3 million years. So that doesn't work. That's then a minute is a lot better. Yeah, so 26 paths. How do I pronounce that actually? 26 factorial. Well, we know of course that there are not 26 factorial paths to check, because you cannot go from A to Z, for example, because there would be a door in between, most likely. So you have to generate only paths that are valid, and I have no good idea of how many valid paths there might be, but yeah, right now, since I'm generating prefixes, that could be a lot more paths than the actual total number of valid paths. Although every prefix I create is a valid prefix, so you could technically add a path at the end. So that means that the number of valid paths should be... No, it's not necessarily bigger or smaller than the number of prefixes, because some paths share the same prefix. Yeah. Oh, we're starting. Sorry guys. Good luck everyone. Anagon Live is starting with day 20 of Advent of Code. Good luck. Day 20. Donut Maze, another maze. Alright. You notice a strange pattern on the surface of Pluto and land nearby to get a closer look. Upon closer inspection, you realize you've come across one of the famous space warping mazes of the long-lost Pluto civilization. Is that a maze with portals? Because there isn't much space on Pluto, the civilization that used to live there thrived by inventing a method for folding space-time. Although the technology is no longer understood, mazes like this provide a small glimpse into the daily life of an ancient Pluto citizen. This maze is shaped like a donut. Portals along the inner and outer edge of the donut can instantly teleport you from one side to the other. For example, this map of the maze shows solid walls and open passages. Every maze on Pluto has a start, the open tile next to AA, and an end, the open tile next to ZZ. Mazes on Pluto also have portals. This maze has 3 pairs of portals, BC, DE and FG. When on an open tile next to one of these labels, a single step can take you to the other tile with the same label. Okay, you can only walk on dot tiles. Labels and empty space are not traversable. Okay, I see. One path through the maze doesn't require any portals. Starting at AA, you could go down 1, right, so on, and to reach ZZ a total of 26 steps. However, there is a shorter path. You could walk from AA to the inner BC portal, warp to the outer BC portal, walk to the inner and the outer and blah blah, and finally walk to ZZ in 6 steps. That is only 23 steps, and here is a larger example. So here AA has no direct path to ZZ, but it does connect through several portals. In your maze, how many steps does it take to get from the open tile marked AA to the open tile marked ZZ? Well, depending on the size of the maze, that would again be a search algorithm. It is really quite large, but we do need to get the shortest answer. How many steps does it take to get from the open tile marked AA to the open tile marked ZZ? And I guess the minimum number of steps that it takes, right? Yes. Okay, so I guess one challenge is going to be to recognize the portals, because they are named at different positions, but we can have a look to see if we really need to parse both letters or if we can actually use only one of the letters. So we have L, M, J, Z, C, R, Y, E and F. So let's see if we do have double names or not. So we always jump from the outside to the inside, right? VM and VM and so on. And EL goes to EL and so on. So L, F, U, M, P and R. So there are no double letters on this side either. And on this side we have J, C, L, E, B, P, F. Oh, but where are those numbers here? SC is there, but ZJ, I cannot find it here. Where is ZJ then? It's on the other side of the donut. Okay, so this one goes... So ML, where's ML actually? I'm just double checking if you can only go in one dimension, like from top to bottom and so on, or if it also jumps from edge to edge. So M is highlighted on the top and here also. So I think that you can only go vertically and horizontally. And it also seems that the portal names are actually so unique that you need only one letter to identify them, but it is a little bit tricky to verify that. Well, what I'm going to do is I'm going to parse the puzzle and download it first. And today, yes, I do spend a bit of time looking at the input because sometimes there are important clues there. And if you don't look at it, you just assume that you need to parse both letters of the input. It can really cost you a lot of time. It turns out to be unnecessary. So I have my day 20 set up to read an input file, and I'll make sure that if I'm going to use nice terminal colors that will work. So now we can read all of the lines, and let's create a grid which will contain all of the positions in a dictionary with the positions as the keys, and the values will contain the walls and the open spaces. Or I could also use I could also write down all of the open spaces instead of the walls, just to make it a bit shorter. So we're going over all of the lines using an index as well. So that means we are doing an enumerate on the lines. And we'll do the same for the x-coordinate. Always rows first so that we can go horizontally. And that will be the tile. And our grid will be filled only if our tile is an empty space. And we'll fill it with an x and y coordinate. And basically it means we don't need to store anything there. We can just make it a set actually. Normally I want to store some information about the tiles, but for here I think it's not important. So let's add to the set the x and y coordinate, and that's it. What else? We need to know if we have a portal, and the outer walls are not important actually. So if our tile is in the alphabet, and if someone knows a trick to generate all the letters of the alphabet more easily, please do let me know. So we have a portal, and then we're going to keep a list of portals. Portals go from one portal to the other. So I want to know first where all the portals are. Portal positions, and that will be a dictionary. And let me see, am I going to keep the name? I want to keep the name and also where it is. But every portal occurs twice. So we have a start and an end, but you can also go the other way. So for each portal I want to kind of keep all of the positions that are attached to it. Yeah, so how can I do that the best? I think I'm going to use a default dictionary with a list so that I can just append it. Import it, and so the default value for this dictionary is a list, so that when we request any item from the dictionary that doesn't exist, it will just make it and return a list. So now we can identify a certain portal using the x and y coordinate, and we can just directly append to it, and we'll append to it the tile. I was gonna say tile, but tile is just one letter of the portal, and that is not enough. So we need to also get the other side of the portal, and the other letter of the portal rather. And now I'm thinking how to do that. I did say before that we need only one of the letters, which might be correct, but I don't know how to verify that actually. I think to verify that I would have to kind of parse it, or perhaps I could transpose it and see if all the prefixes are unique. Or maybe I can search first to see how many portals we do have, how many we actually have. So for day 20 we can check the input and do a regex search. And let's turn off soft wrapping. Right, and I'm going to do a regex search for at least all the horizontal portals. So that would be all the portals that have letters A and Z twice. And then we'll see how many we have. We have 27 matches. That is kind of interesting, because there are only 26 letters in the alphabet. And that means that there is a letter that is used twice, I think. So we have the first one on the top. Here we have one, and we're just jumping around. Yeah, okay, so just by the fact that we have 27 means that one of the letters is going to be double, and that we cannot rely on the first letter to know which portal is attached to which one. So to know which portal is left and which is right, we can rely on the kind of quadrants where we are. but I want to make sure that it would also work for the smaller puzzles, like this one. So can I cut this up actually into different parts? And that is a little bit difficult. I can do that. Maybe... Let's see, I could also do a regex search for all... Yeah, you know what? I can do a regex search for all pairs of 2 letters horizontally, and then I could flip the entire grid and do a regex search for all the pairs vertically, and that would also give me the right coordinates. I think I like that idea. Well, although what I could also do is actually a lot simpler. I could actually just check the right position next to the portal and the position on the bottom and see if that works. So that is actually easier. So we do have a portal, and I want to know the second letter of the portal. So that could be, for example, the grid on the right. Oh, Zarankiewicz has already solved part 1. That is very quick. Well, let me think how that could have been solved. So let's say that you're running towards a portal, and then you're on a letter. If you would run in the same direction, you would know already which is the full name of the portal. But I'm not so sure still. Okay, let's just do it in our way and figure out the name of the portal. Maybe it would help if we have the grid prepared. Not so sure. Yeah, you know what? I'm going to first populate the grid and all of the letters, portal letters. That is a dictionary. And so if we have a portal tile, we'll just add it to the portal letters, which would look like this. So we are saving the position for the portal tile, and then after that we're going to iterate over all of the portal letters, I guess. Not entirely sure. Not so sure about that. Well, in this example it really also looks like you don't need any of those letters. And hold on a second. Are all of the letters like sequential? No, they are not. So we have FU and UF, EL. Yeah, I'm going to do this regex thing. I think that makes sense to do that. Which horizontally we don't have to do specifically. We can just go to the next position in the current line. So we are on the left, and then if current line with position X plus 1 also is a portal tile, just extracting all of the letters so that we can check it easily. So if that one is in the list of letters, we have horizontal portal. And we can only do that when we are not at the very end of the grid. So that means if X is smaller than the length of the line minus 1. So if the line is too long, like I mean it's 2 characters long, then X can be 1 at most. So it must be smaller than 2. That is fine. Then we can check for a horizontal portal. So we have our portal positions with the tile plus the next tile, and that is going to be we need to store the position where the portal starts. And so let's say that we're now handling the right side of the donut, the right outside of the donut. So that means that X is bigger than half of the width of the line. And and I'm not going to make floats, I'm just going to round it. Although I'm not sure why I should do that. Maybe I shouldn't do that. So we're on the right half, and well, even being on the right half is not enough information. We need to know whether we're on the outer edge. Oh, but that is not so hard. Outer edge is just the last two characters. So we could just kind of go over them all at once. That seems to be a lot easier. You know what? Let's do that. So let's just find the left portals for every row. Left portals, left outer portals, the left inner portals, and the right outer portals, and the right inner portals. So it takes a bit of thinking and trial and error before we can come up with the right solution. Maybe you know a good solution for this. If you have a suggestion, please share. We're already overloaded with very hard puzzles in the last few days, so it's for me totally fine to help each other out a little bit. So the left outer portals, they are the first two characters of the line. So we have line 0 till 2. That is a portal, maybe portal. And if maybe portal is completely made up of letters, so that would be 0 is in letters, and the second one is in the letters. Then we have a portal position at not exactly XY, but at 1Y, because the entrance of the portal is on the right for those that are on the outside on the left. Okay. Okay, and now how about the left inner portals? So that means that we have to check a certain specific location and the width of the donut. How can we know how big the walls are, kind of? So we know the width. We need to subtract 4 for all of the portals on the outside. So let's calculate donut size. Left wall size would be, for example, the length of the line minus 4, and then divided by, so we have 5 walls, and here we have 5, but inside we have 2, 3, 4, 5, 6, 7. So the length 1, 2, 3, 4, 5. So on the left side we have 5 by 5, and on the top we have 7 wide and 5 high. So it seems like it's not exactly consistent. We might need to figure out first the width of the walls then. We can do that because after we've already went over the wall horizontally, we know the width of the wall. I feel like I'm making this too complicated. I'm making it a bit complicated. Yeah, using regexes would still be quite easy, I think, but then you would get only an offset and not so much the x and y coordinates, so you would have to translate the offset again. Maybe I can do that. Well, so the other way would be just to walk around the maze and see where you're going, and if you end up on a ladder, you go another step on the ladder to know where you need to go. But then you need to know where that other portal is located, so you actually do need to have that information available. So I'll keep going like this. I just need to know the width of the walls, so that we can do, as we are iterating over the tiles, we can we can basically count the number of hashes and dots in our current line. That, unless we're at the first line, of course, that would be the width of the entire grid. We can easily check if we have the width of the entire grid. Yeah, let's do that. So walls or spaces, those are all of the characters in the line, or char in line, if the character is in either a hash or a dot, and we have all the walls or spaces. And if, let's say, I want to have the size of the maze width. The maze width is, as I said, the length of the line minus 4. So if the maze width is the same as the size of the wall or spaces, like this, then we are at a top or bottom part of the maze. And otherwise, we know now that the left wall size has a certain dimension, and we can keep that. Do you still remember how you went about solving day 7 part 2? It's got me really stuck right now. Day 7 part 2, I'm not sure I know which one that is from the top of my head, but I don't mind to have a look. Oh, with the amplifiers, and then part 2 was about the large integers. Well, I think for the large integers I didn't have to make any changes, it just worked. And you need different phase settings, yeah. And you're not supposed to restart your software. I think it very much depends on how you implemented your IntCode program to solve that one. So what are you stuck on exactly? Like, where is your trouble? So we have a left wall size, and I think we probably need to go over the grid twice. So I'll do that. So the horizontal wall size, that's what I want to keep, and the vertical wall size also. You know what? Actually, we can calculate that just taking the middle offset and just making basically a cross through the middle to know the size of the walls, and we can also do it vertically from top to bottom. Then we know the width of the walls. You need to pop from an empty list on input operation. Well, you can check if your list is empty, and if it's not empty, then you pop. Is that helping? Or if you need to wait for input, you could check if your input list is empty, and if it's empty, then you're just going to break your loop, and upon passing input to your machine, you're going to start your execution loop again. That's how I did it. So I'm actually going to make a real grid. I just realized that lines is basically our grid already, so I don't have to keep a separate grid. So much work. Okay, so let's figure out the wall width. And what we can do to do that is to take the middle line, which is, out of all of the lines we just divide by 2, that is the middle horizontal line. So vertically speaking, from top to bottom, this one is in the middle. And for x, we also want to do that, but we take the length of the first line and divide it by 2, and figure out the vertical wall width. So if we would look at the middle intersection, then we could figure out how many walls and empty spaces are there. So let's get the middle vertical, middle horizontal line, that is actually just lines middle y, and then we count those empty spaces from it. So that is like character for character in this position, then only if the character is in hash and dot, and that will give us the middle horizontal line, and then we're counting how many walls are in it. Horizontal maze tile count, and that is going to be the length, and that one divided by 2 is going to be the wall size of the vertical walls. So our vertical wall size is the horizontal maze tile count divided by 2, and we can do the same for the vertical one. The vertical line is a bit different because we need to go over the rows, and Alex has solved part 2. It is always so confusing to see someone solve a puzzle very quickly, and I'm wondering what it means. Does it mean coming up with the right solution very quickly, or just seeing the problem in a simpler way? And Userman, it worked on part 1, but it is hitting it in the first phase for some reason, is my issue. Right. Well, Userman, if you're willing to stick it out till the end of today, then we might be able to have a look at your code. Right now I am going to focus on day 20. Of course, do ask me specific questions, but later I might have some time to look into your code and see where it's going wrong. So the middle horizontal line, I think I'm messing up a little bit. What is this? I need the middle vertical line, and that is going over a certain range, namely from 0. Oh, actually we can start at position 2, because the first 2 positions are portals, till the number of lines in total minus 2, and that will be exclusive, but the length of lines is always one higher than the maximum position, so minus 2 will give us the right boundaries. And so for every y in this range, we're going to return whatever is at position y and then the middle x, like this, but only if that position is a maze tile, like this. Alright, so let's actually run this and see if I didn't make any mistakes so far. So where are we now? We found the middle y, and we found out that our... You know what, for the input I could have just manually specified it. Not sure why I'm calculating it, but I do want to test it on the examples. Maybe that's why I'm doing it like this. Let's see where we are. Horizontal maze tile count is 70, and that means that the vertical wall size is going to be 35. Let's look at the input and see if that is correct. What do we have? We have selected 35 characters, so that works. And now about the vertical width. So, oh, I think I just crashed it. I did something wrong here. I need to divide the length by 2. And then we calculate the middle vertical line, and then we'll keep the horizontal wall size, and so it is... Oh yeah, okay, this is confusing. So it's the vertical wall size, it's the walls that go vertically, but you could also call it differently. You could say it's the wall width, right? That is a little bit more clear, I guess. This is going to be the wall height. And wall is also confusing because a wall is actually a single tile. And what I mean by wall is I mean the border, like the edge, or how would you call it? Edge. No, the edge is the inner and the outer edge. So let's call it what? The donut is made of dough. Maybe I should call it boundary. Yeah, so I'm referring to this thing here. Let me show you what I mean. So if this is our donut, I'm referring to this one, or like this part. And so I don't want to call it wall because a wall is a hash, and I don't want to call it a boundary or an edge because a boundary or an edge is like the edges of it. Although the edges are not important in our problem actually. So maybe I can call it section. Yeah, it's like, I don't know a good term. Maybe curve. Maybe curve is a term. Cone sections. Okay. Border. Maybe border. No. Maybe floor. Maze. Oh, but they do mention here something about the outer edges and stuff like that. Okay, you know what? I'll just call it wall anyway. And see that I don't get confused. The wall height is going to be... we're going to have the number of maze characters in the vertical line and divided by 2. That is going to be the wall height. Maybe path. How about path? I like that. No, path is also going to be our path that we're tracing. Oh man. Okay, so now we have the wall height as well. Let's see if that works. Wall width is... So sometimes my debugger doesn't show me the values for some variables, and it's unclear why. So you see that here middle x is shown, but middle wall width is not shown. I find PyCharm to be very inconsistent and unreliable. The real challenge here is names. Well, sometimes it is a challenge. Yeah. Naming things, right? One of the hardest things in programming. As famously said by someone famous. So now we are done, and that means that I wasn't able to see if the wall height worked. Yeah, off by 1 errors and naming things. So now I need to show this manually, and it doesn't work. Okay, I need to take the length of that actually. So the number of wall tiles in the middle divided by 2. That looks like quite a bit too much, I must say. Maybe... What is going on? The middle vertical line looks like this. A lot of hashes. A lot of hashes. No portals, by the way. So if we look at this, we can calculate it by hand. Just by looking that it starts at line 3 and it ends at line 37. So it should be 34 lines. And what I get was 58. So that's not right. And we're going over all of the lines with y and the middle x position, and middle x is shown here as 0, and that is not right. I need to take lines 0. Now we have the middle x of 22, and the middle line looks like this with 123 items in it, and I think my range looks correct. The number of lines, so the range is between 2 and 225. In our input it is 3 and 125. So we do have an extra line here. Maybe that's what's going wrong. So I would have to subtract one of those. This is day 18 actually, here. So I'll do -3 for that extra line. And then we get this. And we get... Okay. Well, what do we get if I would also return the Y position? I want to make sure that I'm actually returning the right thing. So it's a tuple with all the positions, and then we should skip a whole lot of them at some point. But it seems like we don't, so I think my middle X is not right. It says 22, but I think it should be much higher, because we have 125 characters wide. So why does it look differently? So line 2 looks like this. Okay, so we're breaking early. So we shouldn't use this first line to actually calculate the middle X. We should use the third line or so. And then we need to make sure that it's not a line with portals on it. And that looks like it is the case. So line 0 and 1 are not right, but line 2 should be right. I want to take the very first line. Okay. Now I think at this point we can probably assume that it's working. So we have 34 characters for the wall height, and I think that's what we calculated earlier. So that is it. Now we know the wall height. Man, that took already like 40 minutes just to calculate the wall height. And in that time, I think Alex would have solved the puzzle 4 times over. So probably what I'm doing now is not needed. Once we know where all the portals are going to be, we can extract them. So we are going over all of the lines to get the horizontal portals. And Aneurysm, you also feel that input parsing was a bear, and by a bear I assume you mean something very awful and intimidating. So for all of the Y values, we're going to enumerate the Y values as well. Well, actually we are enumerating already, and we could do that just before, so that while we're going over the grid, we can actually extract the portals. So if we're on, let's see, the left portal is on position X is 0, so if line from 0 till 2, so we're going over all of the lines, right? Yeah. So from 0 till 2 is, or starts with, no, I want to say that it's a complete, oh, I know. If the first character on that line is in the letters, then it means we have a portal, right? So the portal positions are line 0 till 2, and that is at position X, Y. But I want to keep only the start of the portal, so the start is actually one to the right. From there. Left outer. Then let's do left inner also. So that left inner is when we are at position 2 plus the wall width plus 1. So we skip 2 on the left, then the wall width, and then 1 to the right. That is where the portal will start, on the inside on the left. If that was in our letters, then we have a portal. So that starts. Maybe I'll just keep track of the inner portal's position. That's here. So the position, no, the name of the portal would be going from the line starting at the X, then +1. And the position would be inner left portal X. Now I think I'm missing a bracket here. And that is the inner left portal position. Yeah. Then we have the right inner. The right inner portal X starts at the length of the line -2 minus the wall width -2, let's say, or -1. You have to head out, but your issue right now with 7 part 2 is the logic with handling the extra phases, I think. Okay, well, I do wish you luck, and thanks for hanging out, and maybe we can look over that another time. Do come back. See you again. So the right inner portal X is... my stuff is on GitHub, yes. My link I will show you right here. That is my GitHub link. Posting it here on the channel. And if I want to copy the link, there you go. Hans has already solved part 1 as the second participant in our leaderboard. So it is a sign that this is not an easy puzzle as well, at least for the average programmer among us. So I was working on the right inner portal, and the right inner portal is starting at that position, and if the line at that position is in the letters, then we have a portal. And that means that the portal goes from, that's the right inner portal X. No, we already have it. Oh, why am I... Oh, this is actually the X and Y, and... Oh, I think I'm not doing this completely right. The left inner portal is at position in left portal X, and then... No, we need to know the name. So this was supposed to be the name, actually. So it's left portal name. Let's call it portal name. And we have portal name like this, and it goes from the X till X +1, and the X is the left side of it, right? Yeah. Okay, that is better. So the portal name for the right one is from the line starting at the inner X, and I do want to start with 2 to the left so that we take the left letter of the right inner portal, and then we go until 1 more, and I think I need to do +2 actually to get both of those letters. Let's try that out. So let's say we have a string foobar and we want to take the first 2 letters. We need to do 0, 2, right? So +2. Portal positions are going to be kept, and it is X and Y like this here also, X and Y. Maybe I want to kind of keep not so sure how I want to refactor this if I do. And so the X here is the left position of the portal, so the start of the portal is 1 to the right of the left side. Okay. I've done now 3 sections, 3 sides of all of the portals, and it is really taking so much time. It's really so slow. Isn't there any better way to do this? Really trying to come up with an alternative here. We could of course also check if we have a letter on any of the sides of the portal, so then we have just 4 or any of the sides of the empty space, and if we found it, then in that direction we just have to go twice. And actually I do realize now that here it says CB if you go from here to the left, but you should read it like BC, so you always need to read the portal names from left to right and from top to bottom. So if you're going down, then the name of the portal is different than if you're going up, kind of. Well, the names are still the same, but you cannot look at the names like as you walk over them. Okay, let's really, should I really keep going? Should I keep going with this method, or should I try something else? I feel it's such a kind of painstaking process of figuring it out. Hey Popcorn too hot. I'm not making a command line game. I am solving day 20 of Advent of Code. Advent of Code, you can see it on my channel homepage also, is a daily puzzle competition around Christmas. It starts at December 1st and goes until December 25th. And today the puzzle is like this. You get a text input, it's a maze, and you can walk over the empty spots in the maze, and there are portals and they have names with 2 letters. And there's one portal that doesn't connect to anything, it's ZZ, and AA is the start. And every other portal has 2 letters, and so you can go from here to here and end up here, for example. And our mission is to find the shortest path from the start till the end. And right now I'm still working on parsing the input. Parsing the walls is very easy, but parsing the portal names is very tricky because the names are spread out over different locations. And I want to keep track of the position of the portal that is right next to the empty space, and the other position is not that relevant. But it seems like we do need the second letter to make sure that we are recognizing the correct portal, because this is the example, but the actual maze looks like this. Oh wait, let me show it here a little bit less bright. But the actual maze looks like this, and it is a lot bigger. And those are all of the portals that you can see. And I was trying to figure out if we need the second letter actually, and I searched for all the horizontal portals, and I found that there are 27 of them. And that means that if there are 27, that we have a letter that is reused. And within this list, it's not so clear which letter is reused actually. Maybe I could just search all. Will it be good to store the portal names in a class where it is based off name? Well, you could use that to identify them, but I think just using strings and string matching is also good enough. But my main challenge right now is to know that at this position right here, that there is a portal and it's FU, or UF in fact. And well, I think, yeah, you know what? I'm just going to look at every maze position and see if there's a letter around it, and then based on that determine the portal. So without actually calculating all of these wall widths and so on. I think it's such a slow way to figure it out. So if it's vertically or horizontally aligned, exactly. Yeah. So I do need this Y loop, this first part of the loop. So let's just, yeah, so instead of calling it line, I'm gonna call it row. And our grid is actually the lines right here, basically. And let me take everything except for the last one. So now we actually have a grid. But this is a grid. There we go. And that means that our other grid, which was the set, it's just the empty spaces. So I'll call it empty, and we'll add it to empty. And this one I can call grid. Everything except -1, I think that is correct. So now we have a grid already. Very simple. And we're going to check all the locations around the empty tile. So for that I need a list of directions, which I will just copy from day 18. Because I have that done before. And it was called Darius, I think. Like this. Very handy. And so for each direction, I'm going to check if there is a letter there. So we have the neighbor x and the neighbor y, which is x plus dx and y plus dy. So I'm actually extracting dx and dy. So if the grid with neighbor y, neighbor x is in the letters, then we have a portal. And now we just need to know which direction the portal was facing. And actually, that is very easy because that is told to us by dx dy. So the second part of the portal name is actually twice dx and dy. So the second portal x, you know what, I'll call it px for portal x and py. So we also have portal x2 and portal y2, which is x plus dx multiplied by 2 and y plus dy multiplied by 2. Now we have the two letters of the portal, and I think what actually is the case is that all of the names, wait, do the names kind of go up? Like ML, no, VM goes down, so it's a higher letter than the other one. You only have to look to the bottom and find the second letter, you think. I'm not sure I understand your hint. I think I'm looking at the second letter correctly now, because I'm at a certain position, and if to the right is a letter, then the other letter is 2 to the right, right? Now there's only one different case where I have to flip the letters, and that is when the portal is either on the up to the top or to the left. So when the portal is to the left or up, then we need to flip the letters. And we know that, so if x is smaller than 0 or dy is smaller than 0, then we need to flip the letters. So that means the name is the grid py px plus grid py2 with px2. Or actually, if those names don't need to be flipped, we can do it like this, and if they need to be flipped, we'll just do it the other way around. Like this. And now the actual portal position is pxpy, so we can store that into our portal positions. Wow, that was really a lot easier than what I was doing before. Oh my god. So pxpy. So it does pay off to try different approaches. And no, I want to keep the name, and then I'm gonna keep pxpy. That's all. And as I was saying in the beginning, my portal positions is actually a dictionary that maps the names to the positions that are connected to it. So that I think at this point actually the name is no longer important. It's not important at all. So I'm going to instead map one position to another. So that means I just have a dictionary, and I'm going to map the portal's position to the other portal's position, but oh wait, at this point I don't know it yet. Okay, so I do actually have to kind of keep track of the names. Like this. We have the portal positions that we're gonna keep. Actually, if we're just going to keep the first portal, and then when we find the second portal we're going to link them, that would also work. So then we have an empty set or an empty dictionary of portals, and we're going to store the start position. And if our pxpy is already in portal positions, hey Hans, good job, you are already done as the second person today to finish part 2. How was that? 1 hour? Took about 1 hour? What was the difficult part? Part 1 or part 2? So actually I wanna have p here as pxpy, so I don't have to type that over and over again. You're back at your parents' place, so you didn't have time to check in. Well, that's alright, you're here now. So if the portal position is in the portal positions, then actually we can link them, and otherwise we're going to store it. So let's link it now. So we have our portals, and P links to the other portal, which is like stored here. And the other way around goes like this. So this is the other portal's position. So the other portal links to our current position. So now I think at the end we should have a dictionary of portals linking to each other. So we have portal positions and portals. We can just run it. We do get an index out of range error. So that means that we are checking to the right of the grid and it's outside of the maze. So let's try not to do that. So we need to make sure that we're in the range. So that means that px is smaller than the length of the row, right? We should also get this error from going up. So py is also bigger than 0. We actually need to check that it's inside the entire range, both x and y. So we can do it like this. Px is in the range of 0 till the length of the row minus 1. No, including that one. And should I not check if py and px2 are also a letter? Well, I think we don't need to check that because I do need to check that if I would be here, for example. But if I'm on an empty spot, then I don't need to check it. So that means I need to make sure first that my current tile is a dot. So basically I should move all of this inside the check when we find an empty space, because once we're on an empty space and we find a portal, then the next one is also going to be a portal. Thank you for that question. That is a good one, avoiding some trouble. So if px is in the range and py is in the range, 0 till a length of the grid, and the particular position we're looking at is in the letters, then we are at the start of a portal. Let's see what we get now. String index out of range still. And what is our px and py at that point? So first we have px40 and py, and that should probably work well. And what happens if we are crashing? Can we actually crash and break? Do breakpoints, mute breakpoints. Like something like break on exception doesn't exist in Python. So maybe I'll just print it then, old-fashioned way. Yeah, I could do a try catch, of course. We're now checking 45.1. That means x is 45, and well, the length of the row, how much would that be? So the rows, the first row is actually short because the new lines are here. No, we do have white spaces. Thanks for that, Eric. Eric made all of these puzzles. Eric Wassel. So we have 88 characters, and apparently there's one point where we cannot go 88 to the right. And maybe that is the last line? No, we are on the first row. Row number 1, which is this one. And it's actually my own fault. I'm stripping all of those lines. Well, if I don't do that, it would be different. Yeah. So now we get something else. List index out of range. That means we also need to check if P2 is in range. We can calculate that beforehand. And technically, if P2 is in range, then P1 is also going to be in range. So let's do it like this. Now we don't get exceptions, and we have a list of portals and their positions. And we do have also links from every portal to the other, I hope. But I don't see that. And that is because I'm checking for the position rather than the name. And now we are going to map. Let's see what happens here. Key error. So we're checking for certain offset. Yeah, that means you need to use the name to figure out the other portal, not the position. And now we have a list or a dictionary of portals going from one to the other. Okay. Well, that's a nice first step. Let me commit that. That is day 20, part 1, work in progress. Pressing commit a bunch of times until it works. Okay, now we can actually do our search algorithm. Wow, that is a long way to go. Well, maybe not. Okay, let's do a breadth first search. That means that we're going to keep a list of tiles to visit. Like check tiles. It's an empty list, and as long as we have tiles to check, then we're going to continue. And once we reach ZZ, then we're done. So what is the first tile we're going to check? And that is actually the location of portal AAA or AA. And where do we start in our input? I see AA on the right. Okay. So it might be helpful for us to see if we have reached portal AA. So while we're checking, if we found AA, that means this is the start location of the portal. And it doesn't link to anything either. So our start position is none and our end position is none. And if we see AA, then we are going to keep our start. That's the portal X. And if name is ZZ, then our goal, or what did I call it, end, is position, not position X, just the position, like this. So we'll start by checking our start position. That is the first thing to check, and I want to keep track of the distance that we've traveled and how many steps does it take to get from the open tile marked AA to the open tile marked ZZ. So we need to keep track of our number of steps, and maybe, no, we don't need to check our position, but we do want to keep the number of steps, and we start with 0 steps that we've made so far. But I realized that our starting position is actually not the where the portal starts, because we don't start on the portal. I think we start on the tile next to the portal. Yeah, it has a start. It's the open tile next to AA. That's fine, we have that one. It's X and Y. So the start is X and Y here, and if the name is the other one, we have X and Y also. And I think the portals work like this. If you're on an empty tile next to a portal, then you can step into the portal, right? When on an open tile next to one of these labels, a single step can take you to the other tile with the same label. So let's say you're at DI here, then you can take a single step and end up on the other location. So that means that our portals actually don't jump from the start of the portal to the start of the other portal. They jump from the start of the portal till the open tile next to the other portal. That is something important. So we need to keep not exactly... what do we need to keep? So for every portal, let's keep track of where the portal entrance is. So P is the entrance, and the tile next to it, that is XY. Your utility function for reading puzzle inputs had an extra chump there. There was stripping significant white space. Yeah, that's what I did also. And because of that, you are getting index out of bounds errors on this puzzle. Yeah. So now we have the portal start and the tile next to it. So if we found that our portal was already found earlier, that means that we have the other portal entrance and the other portal tile. So if we step into the entrance at position P, we're going to the other portal's tile, right? And if we're in the other portal's entrance, then we're going to the current portal's tile, which is XY. That is something I think a lot of participants might get bugs in because of this small but very important difference. Okay, so now we have the start position and the number of steps left, and all we need to do is to look at all the positions we can visit, and we don't want to visit any position twice, at least not within the same path. So that means I want to keep the paths also. So we start with an empty path. So check tiles, we're going to pop from that the first one, and that means we have a position, a position P path length, which we don't need to keep anymore because we have the full path. So that is just the path. And why do we get an error here? Unresolved reference. Oh, I just need to write an equal sign. And breadth first search works like this. We're going over all the directions, which means the x and the y in the directions that we could travel. And then we're going to calculate the new x and the new y for those directions, which means we can extract the position into x and y, and that's x plus dx and y plus dy. And let's try to see if we haven't already visited it in this particular path, this particular journey. So if our new x and new y is not in our path, then we can visit it. So visiting it means to append to our check tiles, and to what are we going to append to that? We'll append, of course, the new x and new y position. We'll append to it our path as we add it plus new x and new y. That makes me realize that basically we need to store only the paths, because the last item on the path is actually where we are at the moment. So instead of that, I'll just keep the start position in a path like this, and So X and Y is actually the last item on the path. Well, that was that. That was a lot easier than I thought. And now we need to check if our goal position is actually the start or the end. And now I want to make sure that, yeah, okay, I do keep track of the tile next to AA and ZZ. So if our end is XY, then we're done and we can break. And we'll print the path, which is very long, and we'll print also the number of steps, so that's the length of the path. So this is basically it. Except that we cannot unpack a non-iterable int object, so that means that path is actually not... Oh right, I see here that I'm appending an integer rather than a tuple. So I need to append like this. Okay. Now it's running. We're always appending to the end, which means that we're doing breadth first search. And it is running quite long, but I'm not sure if it's not correct. I'm checking all of the directions, and no, I should not check all directions. I should check only those directions that are actually walkable. So if the position is not in our path and the new X and new Y is in fact in the walkable paths, how did I call it? Empty? Maybe walkable tiles? Then we can append it. So let's run it again. And it already finished. So that means that walkable tiles is probably not being populated. Well, it looks like it is. But why does that not work? Let's have a look and do debugging mode. So, where are we? G, you're reading the instructions and this text is really hard to understand. Maybe scroll down a little bit and just read the input map. I think the visualization makes it a bit more intuitive. But if you're confused about anything, do ask and I'll explain how I understood the puzzle so far. So, where am I now? I'm actually here at parsing the input. That is already done. So I'll keep going until I reach this part. Walkable tiles contains all of these positions. Okay. And we have new X and new Y. 127. Okay. We'll ask when you're finished, but that's fine, I don't mind. Explaining something also helps me to avoid problems. Okay. So we have 6,000 walkable paths, wow. And it says that this position is not in it. Oh, it doesn't show up and you already finished part 1. How can that be? Maybe the leaderboard has crashed a little bit. Let me check about that. Yes, it did check. It did crash. Oh. So maybe some more people have solved the problem actually. So I restarted my server. And yeah, and now I see that Nobali, Crespo, and G have all solved. Oh, and Arcadian Archer also have solved part 1. And there is your reward, and G, you should get one also. Yeah. Okay, I might need to improve my backend code a little bit to be resistant to crashes. And an X and Y is this one, and it says it's not in the walkable tiles. Why is that? No, I did not in fact make this challenge. It's made by Eric Wassel, who spent really like the last few months of the year to build all of this. But I did create a leaderboard that is synced with the leaderboard of Advent of Code. By the way, I do invite you to have a look at adventofcode.com, which link is here. There you go. So it's just a fun addition for those who are watching the stream and joining the Advent of Code event. That on the stream it will be shown which people are participating and how they're doing and so on. Maybe I can look up which position that is in the input. It's 81 to the bottom and 127 to the right. Well, 127 to the right, that is out of bounds actually. First character is character 1 and the last one is 127, but because IntelliJ uses one indexing, that would be 126, I think, one less. So 127 is out of range, and that means of course I do have to check. Okay, but why do I get an index out of bounds? Well, that's only the first item I'm checking, and it's not in the walkable tile, so I can safely skip it. There's actually not a problem going on here. Maybe this one is walkable, yes. And so we do get some tiles to check. And let's render it also. Maybe I can reuse my render maze function from the other day, from day 18. Let's see. Maze. It just needs a grid which contains different. Oh yeah. Yeah, okay, it just needs a grid and an X and a Y and a path. That's all it needs, so I can copy that. Cool. So this is day 20 and we can print a maze. And we don't need doors and stuff. It's not relevant. I just want to render the add sign differently, and I want to render the walls differently. So if we have a wall, then we'll render it a bit differently. And dots will be rendered as spaces. And grid positions work a bit differently also in this puzzle. So it's like this. And we have a min X and min Y. That's something I don't have right here. But we'll just go over all over the rows. Enumerate. That is the grid. And the row is here. And let's enumerate over the row. That is the tile. And why is this highlighted? Why is this highlighted actually? Because we're still in debug mode. Maybe. Oh, I'm starting with an else statement rather than an if statement. Yeah. Thank you. Okay, so this is marked and otherwise we'll print the tile. So let's print the maze every time we're checking. So print maze. We have an X and a Y and a path. And let's break after every step. Does it look right? Not entirely. Not entirely right. Maybe I can check it first with a more simple example like this one, because it's a bit big. So all the spaces included. Right. Let's go to our input file and here add example 1. So let's see if that works. Example 1. No, is that correct? I think that's not correct. Oh yeah, it is correct. Okay. Let's rerun it. And this is the output that we get. It looks fine actually, except that we are rendering new lines as well. and I don't want to do that. So I want to trim all the, and we do right strip of the new lines. Right strip and rerun it. Rotate right strip. No, we cannot do it like this. We need to do it here. So now we are printing a nice looking maze, but it would be helpful to see the floors also. And that means I'm going to actually render the dots right here. And rerun it. Oh yeah, now we have a maze that is visible. And let's see how we're actually iterating over all of this. Every time we're printing the maze, we're gonna break. And it looks like our path is not really working well. The path highlighting is not working. So we pass a path, but I didn't actually check for the path anymore. I kind of left that out. So if the tile is if X and Y is in the path, then I want to render something else. Maybe I can just do like O equals another color, and that is color green. I don't remember green, but I have it here. I used to use, if it's in the path, I used to use 42 for that. So now you will be able to see the paths. Yep. So we're checking and checking, and now I remember what I didn't actually handle yet, and that's the teleports. So we are exploring correctly, and then we're done, because we've tried everything. Hold on a second, I need to take a small break, 1 moment. Yeah, I'm right back. So actually the last thing we need to do is to check our portals and see that they work. So how that works is like this, that if it is a walkable tile, then we can go there, but if it's not a walkable tile but it is a portal, then we can actually step into the portal. So we need to make sure that we haven't visited that yet. So that is going to be a check we always do. And then within those options we have two cases. One is where it's a walkable tile, and the other one is it is a portal. So it is in the portals, and then we're going to append, instead of the position, we're going to append the portal's target, and that is going to be portals NX and Y. That's it. And we rerun it. Now I think it's going to be working quite quickly. So here you see that we actually went to B, and here we went to B also. That looks a little bit like a duplication. Maybe. Let's see, our position that we're checking is a portal, okay. We're appending the target position of the portals. Maybe I should print also the current path that we're taking, just to be very clear. Oh, I am not doing that? No, I'm not doing that. So let's print the path and rerun. Give it a little bit more space. So the first time we step into a portal is here, and we're going from position 9.2 to 9.3, 4, 5, 6. That is going down all the way, and then we'll end up in 2.8, and I think 9.6 should be the portal. So it's 1, 2, 3, for 5 steps, and then 6 is the portal itself, and then we'll end up at 2-8. So that looks correct. And this was another branch we're checking. And it looks like we went back into the portal actually. I think that's not something we want to do. So we want to make sure that I'm not appending the portal's location into the path. I'm actually appending only the target and not the portal itself. So maybe I should... I think here's going to be a tricky part of this puzzle. I want to make sure that the portal is in the list of visited locations, so I'm not gonna go back into the portal as an option. But I don't want to count it as a path, as a step on the path. So how can I do that? I can try, for example, to see if the target of the... Hold on. So if the target position is actually a portal, and I want to make sure that I wouldn't... Hold on. So maybe I should check if the target of the portals was not in the path as well. So maybe I should check first if it is a portal tile. Is portal start like this? And that is the case, like if the position is in the portals. So if NX is not in path and we don't have the case where we have a portal start and the portal target is already in the path, like that. In path. Yeah, so either we haven't visited that place yet at all, and no, so we haven't visited that place yet, and also it's not a portal where we have been in its target location. I think that works. That's another tricky case. And it looks like now we have finished, we have reached the end of our search, but we don't end up at Z. It looks like that at least. Or maybe we do end up at it, but I did put a breakpoint here, and let's see. We don't break, so it means we never actually find the answer. And why is that? Maybe it's because I consider Z a portal start and Z doesn't go anywhere. We don't have it in our portals list. So let's see that. Maybe that's what's happening. Let me break when we do find that the portal is ZZ. Yeah, let's break when we reach the end, so to say. Not entirely sure why it's not working. Maybe we can just break and really go step by step. So there aren't too many options. Actually, you know what? Why don't I try it out on an even simpler puzzle? I'll make my own one. Simple.txt. And that means that we will have a bunch of walls like this, AA, and a bunch of dots going all the way to ZZ. That should work. And we'll try it on that. So we are at... Oh, the bottom is not recognized actually as a line because I didn't add a new line. So this is our puzzle and we are going to the right. And did we actually stop? Yes, we did stop. So this works. And I want to make sure that ZZ occurs only once. And I think it, well, Z occurs only once, but there are some Z's in there that have, that is part of the name of another portal. Okay, so what might be going wrong? Let's try. So I like my solution for finding the portals because it works for any arbitrary map and not just the donuts. So let's say we have AB here, and then we have a bunch of nothing, and AB here. Let's see if we can now travel through that portal. It just finishes without actually breaking, and I have a breakpoint here when we reach the end. And maybe that's because the end is actually a different position than what I'm thinking. Let's see. So before we run our algorithm, let's break. And let's see what the end is. It's 26-1. And I have here position 0 is shown here as column 1. So when I am here, I am at column 28. So this one is at position 27. And in our output we say it's 26. So I think we should actually keep the start of Z as the exit, not actually the tile right in front of it. Because it's not a walkable path, so we're not going to add it to our options. But still, tile in front of Z is a walkable path. That's the one I'm keeping. And so we should end up there at some point. Why don't we? Oh, we do actually. We actually do. And then we are printing. And that is the path. Okay, so that does look correct. Reached ZZ. So we reached ZZ with the following path. Okay. Then what happens if we run it on the input? No, not the input, but example 1. Then we don't reach the end. And it seems like we're not going down at all. Maybe there's a specific reason for that we're not going down, ever. It might have to do with the range or something. I do get some character problems here. Not sure why. So why don't we go down? I also noticed that I see Z here and not ZZ. So maybe our example is also missing an extra new line. Yes, it is. So now we finished? No, we didn't finish either. And do we have the end and the start? So let's just break and check our end position. End is none. So that means actually we are not finding the end of this example, even though I have a new line here. Maybe it has something to do with the spaces being missing from the end. I did not remove them, but maybe PyCharm removed it when I pasted. Well, not so clear. So we have no start, we have no end. But that's because I'm breaking before the loop instead of breaking after the first loop where we find those positions. So we have a start, and do we have an end? None, we have no end. Okay, why is that? We have a name, okay. So again, the white spaces are being stripped from our input. I don't know if that is a problem. It might be a problem. It can happen if we are checking for The length, yeah. Maybe I do need to add one for the Y range to make sure that it works. Let's see now. Our variables. Now we're getting out of range errors. Would be so handy if we could make sure that there was an empty line at the end. So here we do have the empty line. In an example we do have the empty line also. So we're going over every row and then we have the tiles. So we should get the tile with the Z on it as well. And here we're checking if we are in the right, if we actually are able to look at that position, if it's in the grid or not. And the +1 didn't work. It gave us an index out of range error. Well, let's go over all of the rows. So we have now, maybe I should pause here. So we have Y1, no, I should pause here. So Y2, 3, 4, 5, and we do have new lines here, that's fine. So at Y is 18, we should get a Z. Keep going. We can actually see in the line, oh, that was the line, and we stopped already right away. So maybe, it's because I'm removing the last line, and I shouldn't do that. Okay, let's run it now. And do we actually get an output? Yeah, we reached ZZ and we do have a path. So I don't know why I stripped the last line. I think I didn't want to get an index out of bounds error, but we do need to pass it to pass the last line as well. So now we are printing everything, and it takes for some time because it is a lot of output and a lot of places to visit. So I'm going to keep track of how many iterations we've done. I is +1, and if no, I'm doing it in the wrong loop. Having two loops can be very confusing. Like, I'm trying to stop it, actually it doesn't stop. Maybe I can kill it? Yeah, I think it's done, but I'm not entirely sure. Is it still running? View tool windows run. No, it's not showing. View tool windows terminal. Run is not in there, so I guess it's not running. So our loop is going to be counting the iterations. And then I would like to print every 100 steps. Modulo 100 is 0, and then we'll print. We don't print anything else unless we reach the goal. And it is very big, it's a very big output, so I'll make it a bit smaller. Quite a bit smaller. Like this. And I'll show it in a separate window. And usually I was doing a clear of the screen every time, so that's something I'm gonna do here as well. So when I print the maze, I wanna not clear, I wanna decide here when to clear and how to clear. So it's os.system clear, and importing os, and running again. Well, it is rendering very slowly. I'm not used to that. It should normally render faster, so I feel like something might still be running in the background. Let me check. if Python is running. And we do have Python running, but is it taking CPU? No, it's not taking any CPU. So I think that's probably part of my streaming software. And that means there's another reason why it's rendering a bit slowly. Maybe what we can do is to sleep for a tiny bit, like 10 milliseconds. And I think time sleep can take like maybe 100 milliseconds, like that. And then we'll just do it not every 100 but every 1000. Well, it's still very messy to look at and so slow. I'm not sure why that is. Maybe it's because of the in-path thingy. That might be very inefficient. But we did reach a goal. Okay, we did reach the goal and we have 637 steps. And it's not the right answer, it's too high. And now we need to see why that is. So, part 1, too high. It can be an off by 1 error, and that is actually very likely. And for that I want to try it again on my simple example. Maybe I'll make the example even simpler. So I'll have 2 steps here and 2 steps there. Let's reason about how many steps it should be. I'll copy this into a bigger screen. Oh, we cannot actually copy those characters because they are colored. So the size is going to be 16. So how many steps do we expect? We are saying it's 4. Is it really 4? So from here we need to do 1 step, 2 steps, and after 2 steps we'll be here. Then we'll do 3 steps and we'll be at the tile before Z. So I think we're counting 1 step too many. So that means I am going to resubmit my answer with 1 less. So the answer is 236 then. 2, 3, 6. Oh, sorry, it's not 2, it's 6, 3, 6. And it's the right answer. Alright. So I'm happy the way I solved that. So we'll print path length -1. Path length excluding the start is this. And so this is correct. Thank you, thank you, thank you. I'm committing it. Day 20, part 1. Well, I like this puzzle, it was fun. It's a search, but not too many complications, and it's not too heavy on the machine. Now let's look at part 2. And it says the exit isn't open when we reach it, but the Plutonians were famous for building recursive spaces. The marked connections in the maze aren't portals. They physically connect to a larger or smaller copy of the maze. Okay. Specifically, the labeled tiles around the inside edge actually connect to a smaller copy of the same maze. Oh yeah? How does that work? A smaller copy. Specifically, the labeled tiles around the inside edge connect to a smaller copy of the same maze, and the smaller... Oh, the inside edge is different from the outside edge. I see, okay. And the smaller copy's inner labeled tiles connect to yet a smaller copy, and so on. When you enter the maze, you are at the outermost level. When at the outermost levels, the only outer labels AA and ZZ function as oh, that's the only ones that function, and all the other outer labels are effectively walls. At any other level, AA and ZZ count as walls, but the other outer label tiles bring you 1 level outward. Oh man. Oh man, that is wow. That is a bit breaking my brain. When you enter the maze, you are at the outermost level, okay? Right, and the goal is to find a path through the maze that brings you back to ZZ at the outermost level of the maze. So what does that actually mean? It means that we cannot use the portals on the outside, we can only use the ones on the inside, and then we end up on the portals on the outside in the level below. Okay. I'm going to visualize what they just told us, because I don't like to think of it. Well, it's mentioned that they are rings, so we can think of it the way they say, like we have an outer maze and an inner maze and an inner maze and so on. And what is said that we have A and Z, and they are working on the outer rings, but in the inner rings they don't work. So A is not working and Z is not working. Then we have some portals like B and what else? We have the inner portals also. So let's say we have a B here and we have a C and we have a C on the inside. And for those cases, the outer B's and C's don't work, but the inner ones do. And so on the inside we also have the same letters and a C on the right. And for the inner portal both of them work, but the way they connect is actually the interesting and important part. So this inner B connects to the outer B of the inner maze, and and the outer C here connects to the inner C of the next portal inside. Okay, so I'm just gonna draw one level only, and this C connects to the outer C right here. Okay, so that means that our path is going to span multiple layers, not just the outer layer but multiple layers. And if we want to check whether or not we've visited a certain path, then we want to check only within that specific layer and not within all layers. And so our path is going to be not one-dimensional but two-dimensional sort of, or our x and y coordinates are going to be expanded with another z coordinate. So that is going to be my strategy, kind of. Well, it's just a matter of how I store the data, and the strategy I'm not sure yet. I also need to check whether or not we can go into portals depending on at which level we are. But I'm actually going to take a break and have a little bit of breakfast. I will keep the stream open so you don't have to rejoin. I'll be back in about 10 minutes or so. So good luck if you're working on day 20, and otherwise see you in a little bit. Hi everyone, thanks for waiting, I'm back. So, actually I realized during the little break that the puzzle is not that hard. Basically we just have 3 dimensions. We have X, Y and Z, and for layer we can use L for layer or something, and that's all we need. And then while we are deciding whether or not we can travel, then we need to just take into account which layer we are in, and that's all. So let's change our code. Maybe what I would do is I'll actually copy this part, or I'll actually make it in a function called part1 that is going to solve the maze for part 1, and that should be alright. And then part 2 is basically doing the same thing. Part 2 right here. So we're going to start somewhere, but we're going to add to it also the layer where we are, and we're starting at layer 0. And so here we have a duplicate code fragment. Well, that was intentional, so no need to worry about that. And so our path consists of X, Y and Z. So maybe let me actually extract the start position, or maybe what I can do is I need to know the start X and Y. Oh, okay, I know how to do that. Of course, like this. Like this. So the last one will be our layer called Z. Now, here we have a lot of logic, and can I do that with tuples also? I didn't know. Let me see. So let's say we have a start position here and we're adding a tuple like this. Oh yeah, that works. Wow, that's actually pretty nice. So I'll do start plus and then a tuple with one element like this. Thank you. Okay. So there's a lot of logic here, and I want to know a bit clearly. I do realize something now, that the portals connect to different layers, right? And we need to know if we are dealing with an inner portal or an outer portal. And that is something I haven't taken into account yet. So my earlier logic for populating all the portals is now not good enough. The direction of the portal does give us some hint, because whenever we're going up into a portal, we're either on the outer ring on the top or we're on the inner ring on the bottom. So that is something we can use to decide where we're gonna go. And so that means we're on the outer ring if we are actually looking at portals which have an X position all the way on the left or all the way on the right, or a Y position all the way on the top or all the way on the bottom. So that is quite easy, and otherwise we're just on an inside portal. So let's look at our parsing code. So here we check if it's a portal start. So let's check also if it is an outer portal. And it's an outer portal, in which case exactly when an X is either less than 2, so actually either it's 2 or nx equals the length of a single line, so that it could be like grid 0 minus 2, I think. Let's see how that looks. So let's say we have a b hash 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 xy. This is our line, and our position with our length is now 7. So 7 minus 2 would be x. Yeah, that is correct. 0, 1, 2, 3, 4, 5. Yeah. Now we're at the outer portal, but that's only for the case of the horizontal portals. And there's also another case. I'm not sure if I should check also the Y position, but I guess I don't. Even if the portal would be here all the way on the bottom, it would still be an outer portal. So that means these parentheses are not needed. Well, or I'll do it like this, and Y equals 2, or and Y is like the height of the grid minus 2. Well, I could also say that it's like bigger than the height minus 4 or something, just to make sure that I don't get an off by 1 error. So nx is bigger than the length minus 4. I'm assuming that the walls are going to be at least 2 tiles thick. And here I'm missing one closing parenthesis. And this cannot be like that. You have to escape those new lines. Okay. And I do something wrong, apparently, according to Python. Continuation line over indented for visual indent. I'm not sure about that. For me, it's fine to do it like that. Like this. It's even how my editor is doing it when I tell it to make line breaks in there. So sometimes the visual hints like formatting errors and stuff, they're a little bit weird and not that helpful. So if we're an outer portal, we're doing something different than if we're in an inner portal. And let's see, if it is an outer portal, but we're on the top ring, so if Z is 0 and it is an outer portal, and not the start or the end, well, the end is valid. So we are at the top layer and it is an outer portal. In that case, we're going to skip it, so it's not a place we can explore. Oh, and of course also, it's not the end. And portal name. Maybe if we are in a portal. If we are in a portal start, and then in case we are at the top layer, and it's now the portal and portal name, which we can now extract safely. So the portal name is... we don't use the name anymore, do we? We only have the locations. But we do have the name of the end, or the position of the end. So is end equals nx and y. We're at the top layer and it's an outer portal and it's not the end. Then we can actually... I'm thinking now, am I going to skip the outer portals that are not valid, or am I going to check whether they are valid? I think I need to check everything that we can do rather than everything that we can't do. So we can do something if we have a portal start at this position and it is layer 0 and it is the end. Then we can do something. We can go to the end actually. So let me also keep a variable with nx and y as a tuple. So here we can actually say add end, add portal to end. That means that we're actually going to add it like this. And we end up at layer 0 also. and is like this. Well, I think my strategy is not super clear at the moment, what I'm actually doing. Maybe I should draw it out first before I start writing. I think there's something valuable to be gained. So let's say that we're evaluating a certain position. We've already walked somewhere and now we are here. And on the right of us is a portal, like let's say X. Now, if it's on the outside, then we're going to jump inside. And if it is on the inside and we're not on the top, then we're going to jump outside. And also we should not be on the top here. If we're on the outside and we're not at the top, then we're going to jump inside. And if we're not at the top, yeah, actually if we're on the inside, we can always jump to the outside, right? So the inside portals always work. And otherwise, it's just a normal path. This is only for the case of portals. And then we have an extra case for normal. And of course we have a case for walls, which we don't use. And now there's maybe a special case for the end. The end is just the end. So if we are at the end, hold on. So when can we jump from the outside to the inside? Wait a second. When we follow a portal on the outside and we're not at the top, we're going to jump outside, right? I did it wrong. So we're going to jump like a layer up, a level up. And we're going to end up on the inside of that upper layer. Yeah, so I confused inside with going down. It's not the same thing. When we're on the inside, when we're in some layer and we're entering a portal on the inside ring, then we're going to jump up to the outside. Yeah. And the inner... Hold on a second. No, when we enter a portal that is on the inside, we're going to jump down to the outside. One deeper layer. And when we are going to step into a portal on the outside, we're going to jump up. Okay. There we go. And then I want to know the extra case for the start and the end. How does that look? The start, we don't care. We cannot enter the start. Also, we don't have it in our portal list, but that would actually work already. And the end is also not in the portal list because it's not connected to anything. So I think this is going to work. And did I actually add the end portal? Oh yeah, because the end portal is not the portal itself, but the tile at the portal. So it is in our to checklist. So I'm going to just rewrite again from what I wrote down a moment ago. So if we're on the outside and we're not at the top, so at top means that our Z index is 0. So, and if we have a portal, then we are going to do our portal logic. Is portal start. And so if we're at an outside portal and we're not at the top, then we're going to jump one level up. So the new Z will be Z minus 1. And we're going to end up on the inside of the ring. And that is basically just the portal's target. So that logic is basically the same. So the new position is going to be portals and X and Y. This. And the new Z location is actually the old Z location -1. Yeah. And then we're going to check the path as we had it so far and add to that the new portals location. The portals location in the layer. Yeah, the portals target location. And then we add to that the Z coordinate so that we have a tuple of 3 elements. Like that. And the other case was where we have a portal on the inside. So let me write that explicitly. Inner portal. That is just when it's not an outer portal. This inner portal. And that works always. We can always go on an inner portal. That means that Z is going to be incremented like this. And the position is still the target. So we have the same case for both sides of the ring. And what we're going to append is, for both cases, the new Z location and the position of the portal. Like this. And I think I want to try this. I cannot try it anymore on my simple input because it doesn't have a ring. So I'm just gonna have to work with the examples in the assignment. And that one is example1.txt. Maybe this one can work still. I think so. Let's try it with example 1. And so what else do we have? This is our parsing. Here is part 2. And also we need to check if we haven't visited those portals yet. So let's see, if we don't have a portal, then we have just an empty tile, and then we can check if we haven't visited it yet, either by going there directly or by going there through a portal. So if the position is not in the path, and that means that we need to have Z coordinate also, and it's not the start of a portal whereby we would have the target location visited already. Well, we're not in a portal start, we know that already. I think this is the only thing we need to check, whether or not we've visited it. Yeah, so if it's not in the portal path and it's a wall, it's a walkable tile. So, and P is in the walkable tiles and it's not in the path so far, then we're gonna append it, just like I did here above. And the new Z location is just the old Z location, we don't actually change anything there. Okay, and how about portals? We don't want to go into a portal that we've been in before, and to know that we need to check the target position portal. So if the new position with the Y value, with the Z value, I think, well, okay. I am having a bit trouble with the X and Y coordinates being a single tuple, but then here it's like a single tuple. Maybe I should extract it actually. So that would be the target X and target Y of the portal. And then we have target set here. And I want to know if that has not been visited yet. So if the target X and target Y and target Z is not in the path, then we are actually going to append it. And I'll do it just explicitly like this: Tx, Ty, Tz. Just like that. And Tz is highlighted because it might be referenced before assignment. Can that be? That would be the case when we are in an outer portal and we are at the top. So that is another case that we have to handle. That will be a wall. So for that case we would just skip it, I would say. So if we're in an outer portal and we're at the top, then we're going to continue. So I don't think that our editor is going to understand that TZ will always be initialized, but we know it. See, Emmy Flake has finished part 2 also. That's very nice. I also want to finish part 2, so let's keep going. And our new position, that is actually shown here as NX and Y. So let's do it like this, NX and Y and Z. Then we're going to add this one to our paths. Okay. Now I think the logic is mostly complete. I do have is and here as a check. I think I probably don't need to do that, because the end is just a normal tile. That's it, and maybe we can now render it. We need to also show which level we are, otherwise it would be a bit too unclear. So we're printing the maze and we're printing also maybe the path, and let's print the level. That is Z. And we'll sleep a little bit. Alright, let's run it, and maybe I'll go over every step instead of every 1,000 steps for now, just so that we can see how it works on our simple example. So I will pop this out, a little bit more space, and here we're parsing the input. I don't need to break there. And we say that we are already finished because I didn't actually run part 2. So we're gonna run it. This is our grid and we're at level 0. And when we make a step, oh, it says we're already done. But I think we haven't added anything to our to checklist. So let's see why that doesn't happen. So we are running and then checking if we're an outer portal and at the top, and we're going to continue. But AA is an outer portal, apparently, according to our grid. It is in the list of portals. Okay, but did I actually add AA to the portal list? That was not my intention. So portals is populated only when we find 2 portals, right? Otherwise we only keep 2 portal positions. So why do we think that we're at a portal right now? Oh, here we say that we are... Ah, okay. I see what happened. So we are not at a portal start, actually. So we are not at an inner portal just when we're not at an outer portal, but also we need to be at a portal start. Yes. Yeah. Let's rerun. So, are we at an outer portal? It says yes. And we are at the top also. But we are at a portal start? No, we're not. So, how can it be? Ah, we're also only at an outer portal, of course, when we are at a portal start. Like this. We run it. 1 step. So, now, are we at an outer portal? It still says true. Even though outer portal start is false and outer portal requires those other parameters, but I need to put parentheses around it. So I think once you use parentheses, you don't need those slashes. So now we can do it correctly. So, are we at an outer portal? Still yes. Why? So we're not at a start. An outer portal is only an outer portal when we are at a portal start. Or maybe our code didn't save or something. Let's rerun it. We are at an outer portal? No. Finally we are not. And we are at the top. So we are gonna continue checking different directions. I'll just run it one iteration and it didn't do anything. So maybe there's something not working here. Just a bit of extra coffee to stay up. I have slept a bit more than usual, but still feel quite tired. So we're at an outer portal and at the top, are we or not? I need to step. No. So is it a portal start? No, it's not a portal start, so that means we're going to jump to the other branch. Then we need to know if it is in the walkable tiles. And walkable tiles is not a 3-dimensional set. It's only 2-dimensional, so we don't need the Z coordinate. But for the path, we do need the Z coordinate. So that is a little mistake. So we can run now, step over it and see that we are appending, and it means we can keep going over different iterations. But for the case of portals, I do want to kind of break and see what happens. Also, I noticed that our paths are not being rendered anymore. That is because our paths are now 3-dimensional instead of 2-dimensional. So let's pass the 2-dimensional part of the path to our rendering function. Like this. And let's pass only X and Y. For now, I'll continue with what we have because the paths are kind of clear. And we're going to enter a portal path pretty soon, I hope. It seems like we're not actually going into portal BC, so it seems that portal start is not working very well. Let's see why that is. Oh, now we get some invalid syntax. We need to always put parentheses when we're returning tuples in a list comprehension. So here you see what it's doing. It's reaching the end, but it's not using portals. Okay. So how do the portals work? So are we at a portal start now? No, we are not. So we can just keep going. We are going to the right and we are going down. Takes a bit of time. Okay, now we are here and we're evaluating position 8, 6. And I think B is at 8, 6, I'm not sure. 0, 1, 2, 3, 4, 5, 6, 7, 8, yes. So we are now evaluating the position where B should be. And we have said that it is not a portal. Let's look at our variable with the portal positions. So BC is, oh, it's actually at position 9, 7. So I miscalculated, I misread that. And it is at 9, 7 and 9, 6. Hold on a second. Why is that a tuple with 2 variables in it? So we are appending our portal positions? No, we're not. Portal positions. We don't... Oh, wait. I have P, which is the entrance and the end. And actually in the end I don't think I'm using this variable at all. So it's not necessary that I keep it this way. And also, those are the 2 positions of the portal. Not just the start and the end, but like the 2 letters, basically. So it's at 9.6 and 9.7. The horizontal position is 9 and the first height is 6, and we are evaluating y is 6, and just that the x position now shows 8, and because we're going to the left, so that's not really what we're interested in. We're interested in going down like this. No. Okay, I think I probably missed the part where it's evaluating BC. Let's run it again. So we are going down. I have to be careful not to go too fast. Oh, here we are. Now we are evaluating going to the right. I want to see how about going to the bottom. Here we are. But now we're evaluating going up. Does that mean that we are thinking that we were an outer portal or something? I think that's what we were thinking. Ah, no, there we are. Okay, so dy is 1, dx is 0, and we're breaking at discontinuous statement. So it means that we're thinking that we're an outer portal, but we're not. And we are an outer portal in case that nx equals 2, but it doesn't. Or nx is bigger than... so it's bigger than it's kind of in the last 4 pixels on the grid. And so let's look at it. If that's the case, so our grid is 11 wide, minus 4 is 7. So it means that we're taking already everything at the last 4 or 5 digits as being on the right, but it doesn't seem to be like that. Like, let's look at this. So it's 19 characters, right? And then we'll take 4 less, which should be 14 or something, or 15 or 17, but not 11. So why is the length of grid 0 wrong? And that's because the first line in the grid contains only portals and it doesn't go all the way till the end. So at this point I really feel like I need to have a grid width and a height. So let's keep that. So the width will be actually the highest x position we will find, plus 1. Or we will just take the third line from the grid instead of the first line. So the width is based on the third line. And then, since we know that it's probably going to be stripped of spaces, this is a very clunky way to do it. Would be nice to be able to rely on white spaces, but we can't. So are we going to get now through a portal finally? Yeah, now we are at a portal start. That looks correct. And that means the target location is going to be 2 and 8. So 2 to the right and 8 down. That is correct. And let's see if we realize that it's an inner portal, so that we should go to the outer one a level below. And did we calculate TZ yet? We didn't, so it means that we didn't evaluate this part. And we are actually an inner portal, so we are going to increment TZ. And we haven't visited yet, so we're going to append it. That's it. So let's keep running this and see how it looks. So you see the levels actually going up and down. And for this first example, wouldn't you say that it is the fastest to not take any portals and just go around all the portals? We are doing a breadth first search, so it means that we should still find the shortest path. But at this point we might need a heuristic to kind of estimate how many levels we need to travel or something. So that we don't estimate just the distance to Z, but the distance to Z considering all of the levels as well. Now it says that the fastest way to do it was actually to go, well, go from AA to BC, and then we're on an inner level. Then we're going to DE. We're going to be on an inner level as well. And then we're going from here outwards, we're going one level out. Then we're here. But then we are not at the outermost level, are we? I would think we're not at the outermost level. So the end should be X and Y, yes. But also that Z should be 0. Yeah. Now we've reached the end, so let's run it again. And we are sleeping now every time. Maybe that is a bit too slow. But let's print it every 100 steps. So that we can find the path more quickly. So now we are doing it like this. We're going from A to B on the inner ring. Then we're going out again to the outer ring. And then here we're going out again. Okay, so we went in twice. So now we're in, and then we're going out once, and then we're here. Oh, but this is not actually the grid that solved the puzzle, I think. Or is it? No, it might not have been. So let's print the maze again. Here. So this is actually the path that we're taking. We're just going around and not using any portals. Okay. That is day 20, and now on the actual input. And yeah, it's very big again. So I'll change the output size. Maybe like 5 or so. And it takes a long time to render. That is really the bottleneck. Maybe I'm going to render it even less often, like let's say every 1,000 steps or something. Wow, it even keeps going, even though I already told it to stop. So every 1,000 steps, or yeah, like that, we're going to render. And let's not sleep. And also, I want to print the number of iterations we've done. So let's print that. Print I. Maybe with a hashtag. Let's run it. Maybe let's print I before the maze, because we actually never get to see the end of the maze. So we've now done 10,000 steps. Well, actually this can take a long time, and maybe what I want to do is not print it at all. Well, sorry for that kind of changing of my mind, but and I do want to see how many iterations we've done. So every 1,000 steps I'm going to print the number of iterations and clear the screen and say what level we are at, just out of curiosity. And then I can use a bigger font. So we do go quite deeply actually, and we are doing really a lot of steps, a lot of cycles at a time. I don't know if breadth first search is going to work. Maybe it's too complicated, maybe it will take too long. Yeah, I don't know how many ways there are to travel. Maybe it's really too much. And also it's difficult to know if you're near the end or not. Well, you can know by taking the kind of distance to the Z location. But yeah, you don't know, of course, how many levels you're gonna have to go up and how many steps it takes to go up one level. Because Because if you wanted to go up a level, you cannot just take any portal and consider that you're up. There are many portals to use to go up. So yeah, it's not that clear. Now I am getting curious also about my memory usage, because I might just run this, until it's done. Oh, this is actually an output from the debug version. This is still running. Memory usage should go up. We have now used... oh, we don't use that much actually. 220 MB. Okay, that's a good sign. That means that... you couldn't see that actually, I just realized that right now. So we can just keep this running for some time. I'll keep the system monitor on screen to show you the memory usage. It's showing on the right. And yeah, as long as memory usage isn't a big problem, we can just keep this running. And then I would like to know when it's done, but I'm not sure how I can do that. I could call myself or send a Telegram message or something. Hey Arcanian, how is it going? I think you finished already, right? Yeah, you did. How long did your second part of the puzzle take to run? I think I have a solution that is just simple. It's breadth first search. You've been alright, but very busy. And was that because of Advent of Code or other things? A second or two? Oh no. A second or two. Okay. I think you might have used the same kind of optimization as in 18's puzzle of day 18. So you only use BFS, but do you use BFS on single steps, or do you use BFS on going from portal to portal? Advent of Code certainly isn't freeing up any time, but it's mostly because of some essays I have to write. You're taking single steps and it takes only a second or two? But then what am I doing wrong? Can you help me out? So I am starting with a certain tile at the start position at level 0. Then I'm going over all the tiles and I'm popping the first item. And then I'm going over all directions and I'm calculating the new position where I might travel. And then I do check whether they are portals or not. Maybe that check is very slow and I should first check if it's... Well, I do have to check for it. I can use a cache for my BFS, but what exactly am I going to cache? And G says that they know what to do, just write another BFS. But, okay, you're using a DQ. So you're using a DQ... so that's just to make popping a little bit more efficient. But what am I going to cache exactly? Checking whether something is a portal start or a portal end, that's something I could cache. Other than that, I'm not calculating anything. I'm not calculating any paths or something. Well, something you could do at this point is to run it with kind of profiling and see what functions take a lot of time. You guys need a few seconds to get an answer or to prove that it is the right answer. Because I get the answer in a few seconds, but to prove it is the best, it takes around 30 seconds. And Alex is not caching anything. No, BFS is optimal, yeah. That's the whole point, right? If you're always checking the shortest path so far first, and once you find something, then you're going to find the shortest path, and then you can just break. And I am breaking, right? Yes, I am breaking. So I'm not sure why mine takes so long. I'm using a lot of list functions, like I have nx in portals. I have here tx not in path, and maybe it's because I should keep a set or something. And you use a priority, so it takes a bit of time to run every possibility. But if you're using a priority queue, that means that you're also sorting by the smallest path so far, right? And what I'm doing, yes, that's also what I'm doing, kind of. By the way, there's something that's kind of confusing me. I used to have, when I did a breadth first search, a list of visited nodes. Like I kept it separately from the tiles to check, but nowadays I keep my list of visited nodes inside every state. Is that a different approach, or is it equivalent? Like, because there are multiple ways to visit a node, I don't want to kind of keep a global list of nodes that I have visited. Is that logic sound? Oh, and you prioritized floor number, so that means you're always going to try everything on floor 0 first. Ah, okay, that might help. I'm going to commit and see if I can add that little heuristic. Day 20, part 2, work in progress. And yeah, I also would like to see Alex's solution, and we can do that in a moment. How much time do you guys have? Like, if you don't have a lot of time, I would look at Alex's solution first, and otherwise I will just first try to prioritize the lower floor numbers and see if that helps. So to prioritize the queue, I would have to have not only a list of paths, but I would have to have a priority. So let's do it like this. I'm going to stop my code here. So the priority will be the first item. And then when we add something... Okay, so you've pasted it. Let's have a look then. The link. Thanks Alex for sharing. So it's very ugly and you copy pasted everything all the time. That is okay. Ah, well, it's something I kind of didn't, yeah. Well, let's look at your code. I think you copy pasted some code for detecting the portals, and I was so stuck on that. I didn't find a clean way to do it until very late. So let's create a Python file. Alright, so we start out by parsing the input, and I see you've used my path. Thank you very much. Let's run it. We get 636, that is my answer also, and then another path. And you hope it works on other inputs too. Well, part 1 is correct, and part 2 I don't know, of course. Properly detecting the portals was most of the work for me. Yeah. Let's see how Alex solved it, and maybe how Arcanian Archer solved it also, and let's compare. So you taking a default dictionary, which returns a list by default. That is actually interesting. Instead of a lambda that returns a list like this. That's what I was doing all the time. You could just like show, like pass it the list initializer function as a lambda. Yeah. So we're going over all of the positions, and you're subtracting. You're going to over all of those ranges except for the empty lines and the ones where you have the portals. Okay, so you're taking only positions where you might find an empty space. And if you have it, you're calculating the neighbors. And for each neighbor, if you actually find a dot, you're going to append it to neighbors. Okay. Ah, that's what you're doing, I see. So you're going to have a kind of graph where every position has a list of neighbors. So that is different from what I'm doing. So that's the part that I can cache. So instead of going over a position and then going each time over all of the neighbors, you just have all of the neighbors cached. That's a good optimization that I will apply to day 18 also. And lin means links, I guess. Well, what is lin? Lin is the line, I think. Line. Yeah. But where's lin? I don't see lin being defined anywhere. Oh, it's all of the lines. Okay, so lin is all of the lines. So you check every angle, and if it's a path, then you're appending it. But what if it is a portal? So if it is, oh, string ASCII letters. So there we have the alphabet. That is something we could use. Instead of writing the alphabet every time, I could use string.ASCII letters. That's a nice improvement. And if it is, then you're taking the label. So if you're on the left finding so if you're finding a portal on the left, or actually above you, then you're going to take the letter even one more above and adding the other one and adding it to the list of neighbors, and you have label to position. So that means that you do have a kind of dictionary, but that returns an empty list. So that is empty right now. So you're appending an empty list, right? Yeah. There's also one for upper and lowercase, so like string dot. Ah, ND. Nice. Okay. It's empty the first time, but contains a portal the second time. So the first time you're appending no other neighbors for this particular portal, and then then you're going to append to this the label and add Y and J. I see. So the second time you're appending. But how do you know if it's the target or not? Oh, it doesn't matter. Basically, you're keeping the tiles next to the portals. So in either direction, the kind of linked tiles are the same. It would actually work with more than 2 doors with the same label. Alright, that's interesting. Yeah, so I was actually storing the position of the portal itself and then the target tile. That means that if you want to go back and forth from the same portal, you're not just jumping from the same tile to the other tile. You actually have to go into the portal. And that means that I would have had 8 cases of links to make instead of 4. I think that that is what makes my code a little bit more verbose than it might have otherwise been. And then so for every neighbor you found for this particular tile, you're going to append it. And actually you're appending also the neighbors for the portal's position. So that makes basically it makes it possible to not think about portals at all. Yeah, actually you don't have to think about portals anymore at this point. So when you're doing your breadth first search, it's just very simple. Just go over all of the neighbors, and if you haven't visited it yet, then you're going to append it. And N, so distances is, oh, okay. I see, okay, so you do actually keep track of all of the positions you visited with the distance to it, and you're not going to visit that location if you've already visited it in any other path that you've traced. Because you're doing breadth first search, you know that if you visited a location, then that was the shortest way to visit it, and any other attempt to visit that one again would be less short. Now I understand why my algorithm is taking so long. I didn't take enough advantage of the fact that we have a guarantee to always have the shortest position. So I very much feel like implementing that right now in part 2 of day 20. So our second part here we can actually keep a list of checked tiles, maybe just empty, or like an empty dictionary. And so if we've checked it here, That means we have x, y, and z. We can append it x, y, and z. And we keep the distance, that's just the length of the path. And then, if we have checked it already, then we're not gonna check it again. So if an x and y and z, so the z will be calculated after we check for portals. So that's a bit inefficient in my case. So if tx, ty, and tz is not in the path and not in the checked, and tx, ty, tz is not in the checked tiles, then we can append it. And that is the same for case of no portal. That's like this. Now it should really be a lot faster. And we do get a syntax error somewhere. Although that just might be my editor being a bit slow. I don't see any red lines highlighted anywhere. Let me just run it. I think you meant to write checked. Yes, thank you. I need to write whether I've checked it or no. I think you meant to write checked instead of check. Ah, okay. Check tiles. Yes, you're right. Checked. Indeed. Yeah, indeed. Okay. So I have checked tiles and checked tiles. Yeah. And then when I do check it, I'm saving it here. That is correct. And we do get an error here. So that was because I was starting to implement a priority, which I haven't finished yet. So let's not do that for now and not write a priority. And now we can run it quickly, hopefully. And it's checking a lot of iterations, but we don't know, of course, if it's going to reach the Z very quickly or not. If I'm not that optimal, it would still be maybe 100 times slower than a few seconds. So we'll let it run in the background while we continue looking at Alex's code. Yeah. So you originally changed by part 1 to this. Okay. So you copied it and changed it. Okay. So this part looks a little bit different. So now you're checking the label, and instead of handling it with 3 lines where you check the label, add to the neighbors, and have a map of every portal to its position. That's okay. Now you need to do something different, because if you're now looping over the positions, over all of the positions for that particular portal, and I think X is in this case a Y and a Z coordinate, X and a Y coordinate. And if you are on the left side of the, no, if you're on the top side, that means you're having a, hold on, if you're on the top side, you're on the outer ring, right? So that means that you're setting the position. Basically jump out is a dictionary that keeps all of the jumps from the outside ring up, and you're appending X. And X is just a location, and you don't keep a Z coordinate or something like that. To jump in, you're taking the opposite. Yeah, so you have in and out, okay. And you do the same thing for every side of the screen. So here you're below the half, otherwise let's see, what is the difference between this one and this one? That is depending on which side of the empty tile your portal is. So if your portal is on the right of your tile, that means you're looking at either the outers. Sorry, this is not the left side, this is below you. So the portal is below you, and that means that if you are on the bottom half and the portal is below you, then you're dealing with an outer jump, jumping outwards. And otherwise, if you're on the top half of the screen. That means you're actually looking at a portal on the inside, and you're jumping in from there to the target location. And yeah, so you're only actually handling those jumps on the second time you iterate over this list, the second time you find that portal's label. Okay, I see how that works. And then you're doing a DQ, and a DQ I learned recently that is just a list with a left and a right side, and it's not prioritized at all. So you're popping left and right. No, you don't pop right. So if the vertex is the goal, you're going to print the distances to the goal. So that is basically the distance to the goal and breaking. And otherwise, you're checking all of the neighbors in the graph that you've pre-made. And then if you haven't visited it before, then you're going to append it. And otherwise, if it's a jump, if the neighbor is a jump, then you're going to append the new location, which is nx and y, and then incrementing the depth, and you're going to append that to your queue. And you're keeping also the distances. So that means you're actually saving it into your visited list before you've actually popped it. I always do it the other way around. And why is that? It doesn't matter actually. I'm not sure if it matters. And here, if the depth is more than 0, then you do something else. Hey Emily, good morning. We are working on part 2 and you are finished with part 2 already. So I am trying to see if there's an overlap between those 3 cases. So here you're actually looking over all of the neighbors, and here you're checking if you're deeper than the top level. And if you're deeper than the top level, then you need to look at the jump out options also, and otherwise you don't. Yeah. Graph is only within the grid without